This is geometry, section 9.3, rotations in the plane. So just like we talked about with reflections in the last section, we're talking about rotations in the plane, meaning just rotations across a flat surface, not in three-dimensional space. So a rotation is an isometry. We've talked about that word before. Isometry is just when you transform something by moving it, but you don't change the size or shape of it. So a rotation is an isometry where figures rotate around a point called the center. So we call this the point of rotation where we're rotating around. We call that the center point. We also rotate by a certain angle. So I rotate around a point by a certain angle, 90 degrees or 180 degrees or 360 degrees or whatever. So to find that, in class we're actually going to use protractors and measure these angles, but I can't use a protractor on this video, so we'll do the best we can. But to do that, you're going to draw a line connecting the center and any point on the image. So the image is the second or the resulting shape, and then you're going to connect the center to a point or the corresponding point on the pre-image, so the matching prime letter, so A and A prime, for example. So we'll start with N. This would be our center of rotation. Okay, so it says verify that each figure was rotated about the origin. The origin is 0, 0. So we're going to connect 0 to N and 0 to N prime. And then we're going to use a protractor to measure the angle between these two lines. That's going to be our angle of rotation. So when we do that, we'll get that it's about a right angle. It's about 90 degrees. Okay, and it would be the same no matter what letter we chose. So if we chose U and U prime, notice that this line right here is below or further away from this line right here, but this line is closer to this line right here. So it makes the same angle either way. So this would be a 90-degree rotation, and we're also going to talk about the direction of the rotation. We're going to talk about either clockwise or counterclockwise. So this one is going from here to here because this one has the primes on it. So this would be counterclockwise, the opposite of a clock. Okay, and same thing for this one. We'll just do A because it's closest to the origin. So A prime and A, if I measure that angle, when we measure that using a protractor, we get that it's about 40 degrees, something close to that. Okay, so 40 degrees. This one's going this way because these ones have the prime, so it's going like a clock, clockwise. Okay, this example. So we've got a regular octagon here, an 8-sided shape, and it says that each of these angles right here is 45 degrees inside the octagon. So we're going to use the diagram to complete the following. First one says a clockwise rotation of 45 degrees, so basically one spot, 45 degrees about. So when it says about, that means that this is the center point. So about means the same thing as around. So around N, or the center is N, and it maps S is right here, onto something. So it basically means S turns into what point after I rotate it 45 degrees around N. And we're going clockwise. So clockwise is this way. So we're taking S and going 45 degrees, or basically one spot, clockwise. So it turns into F. A clockwise rotation of 135 degrees around N maps H onto what? So now we're still going clockwise, but now we have to figure out, okay, 135 degrees, how many spots is that? Well, this is 45. Another 45 would be 90, and another 45 would be 135. So we're going to have to go 3 spots this time, and we're going to end up again at F. A clockwise rotation, so we're still going clockwise, of 90 degrees, so that's 2 45-degree spots. 45 plus 45 is 90, so 2 45-degree spots around N maps what onto A. So now we're going backwards. We're saying, okay, if I end up at A and I'm going clockwise, what point would I have had to start at if I went 90 degrees? So I really just need to go backwards. I need to go counterclockwise 2 spots and figure out where I would have needed to start. So if I go backwards 2 spots, I'm at U. So U onto A would be clockwise 90 degrees. A counterclockwise rotation of 225 about N maps M onto what? So M is right here. We're going counterclockwise now, so this direction. And we need to figure out 225 is is how many spots. So 135 was 3 spots. If I go another 45, that would be 180. And then if I go another 45, that would be 225. So I need to go 3 spots, 1, 2, 3, and then another one, and then another one. So I would end up at H. A counterclockwise rotation of 135. So again, we know that's 3 spots, but we're going counterclockwise now. Around N maps S onto what? So counterclockwise, 1, 2, 3 spots puts us at T. Counterclockwise rotation 45 degrees, so only 1 spot maps what onto U. So we're trying to figure out the pre-image. We're ending up here at U, and we're going counterclockwise 45 degrees. So basically I need to go clockwise 45 degrees. So if I go clockwise 45 degrees, I'm at M, so that means that going from M counterclockwise 45 degrees would put me at U. So M onto U. All right, so to figure out this angle was given to us right here. So to figure out that angle from one vertex to another, or from all these letters, one to another, one vertex to another, we know that a full rotation is 360 degrees. So to figure out what one spot is, we just take the number of letters or the number of sides and divide 360 by that number. And this only works if we have a regular shape. If we have an irregular shape where the sides are not the same length, then this isn't going to work because we're going to have different angles at every spot. So it only works on a regular polygon or a regular shape. So a regular polygon, we're going to take 360, the total for one rotation, and divide it by how many spots there are. So N being the number of sides. So we knew that the angle of rotation from one point to another on the octagon was 45. Well, first of all, because it was given to us, but also because if we apply the rule that we just wrote, 360 divided by 8, or 8 sides, gives us 45 degrees. So if we had a decagon, which is like this shape down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, then we take 360 and divide by 10. So the angle in between each point would be 36 degrees. So how many degrees would it take to rotate point A to point E if we went clockwise and then if we went counterclockwise? So A to E, if we go clockwise, is 1, 2, 3, 4 spots. Okay, so 4 spots, and each spot is 36 degrees. So we just take 4 times 36, and that would give us 144. So 144 degrees clockwise. If we went the other way, if we went counterclockwise, we would have to go 1, 2, 3, 4, 5, 6 spots. So now I would need to take 6 times 36, and that would give me 216. Another way to figure out that second part, once you've figured out the first part, is if this is 144, I know that the whole circle is going to add up to 360, so I could just take 360 and subtract this piece that I already know to get this piece that I need. And last thing, one last theorem. This one's a little bit complicated. It combines a rotation and a reflection. So it looks a little bit complicated at first, but it'll make more sense when we take a look at the diagram. So if lines K and M, like we have in this diagram right here, line K is right here, line M is right here, and they're meeting at a point, they're meeting at this point right here, P, with an acute angle of, we're going to call it X for right now. In this diagram it's 66, but we're just going to call it X when we write out this theorem. Then a reflection across K, so if we look at these 3 shapes, this is our starting one because this doesn't have any primes on it, and then it turns into this one because this has primes on it, and then that one turns into this one which has 2 primes on it, or double prime we would call that. So we reflect first across K, followed by a reflection across M, so this red one flips over M to turn into this green one. This whole process, so flipping it over this line and then over this line, is the same as a rotation of 2 times whatever this angle is, which we called X, so 2 times X degrees around this point where the 2 lines intersect, P. Okay, so again, using this diagram, if triangle RST is reflected over line K and then line M, so we can see that here this blue shape is turning into this red shape, which then turns into this green shape. Blue flips over K to turn into red, red flips over M to turn into green. So if that happens, then that's the same as if we just took the blue shape and rotated it around P, and it would turn into the green shape. So the measure of this angle from R to P to R prime, so I did T to P to T prime, but that would be the same thing. So the angle is going to be 2 times whatever the angle in between the two lines is. So 2 times 66 is going to be 132 degrees. It's going to be the same thing, like I said, it's the same thing for T. It's going to be the same thing for S. So from S to P to S prime, it's still going to be the same thing, 132 degrees, because each point is rotated by the same amount. That's what happens with a rotation. So T double prime, S double prime, R double prime is a rotation of the original triangle, TSR, by 132 degrees, centered around this point P. Another example. So we say that line PQ, so PQ and W, oops, Q needs to be here because both of them have Q. Q is on both the lines, so PQ and Q is right here, P is right here, W is right here. So PQ and WQ intersect at an angle of 80 degrees. We'll say this is 80 degrees right here. Triangle CAB is first reflected over PQ. So triangle CAB is first reflected over PQ, so it would turn into B would flip right here, A would flip right here, and these are primes, so B prime, A prime, C would flip over here, C prime. So flipped over PQ and then reflected over WQ. So now I'm reflecting this whole thing again. So A would come here, C would come here, B would come here. So A prime, A double prime, C double prime, B double prime. And obviously this drawing is not perfect. So we've got our 3 triangles. This is equivalent to if I just took this original triangle and rotated it around this center point. So if I rotated this whole thing around here, C turns into C double prime, A turns into A double prime, B turns into B double prime. The angle, so I would rotate around the center point, the point where the lines intersect, Q, and the angle is going to be twice as big as the angle in between the lines. So it's going to be 160 degrees, or 2 times 80.